All right, here we go. Hey, welcome everyone to April's second Tuesday seminar. Thank you for joining us. Today we're covering the top 3 color problems that printers said they had when they responded to a survey. And actually, today we're just going to cover the first problem because it requires us to set the stage on how to quantify color differences and what kind of color differences there can be. So we'll cover the other 2 color problems in next month's webinar. So as of late, I want to make sure everyone follows us on LinkedIn, please. And then I want to share with you that we've added a sales directory within ChromaChecker. And we're checking our database, and some of our customers have signed up for the sales directory. Please, if you have ChromaChecker, please go into your main menu, pull down menu within ChromaChecker, and you'll see the printer sales directory. And this allows you to promote your business to other ChromaChecker users that need to offload work onto you. So take the time to fill this out. You'll get hopefully new business from this. I know one of our customers had 1 million new jobs last July because they're using ChromaChecker, and the brand company needed to use a printer that was using ChromaChecker to know that their expectations were going to be met. So a lot of other QC software hide this information. We want to make it very open so that it promotes business and commerce within our customers. Now, something else that we've added is a YouTube channel. So please go to this address on YouTube and subscribe. Any of you who were at last month's session, you probably found this because I was in the Bahamas during the second Tuesday. So I was in no position to broadcast a live webinar. So I recorded it ahead of time. And we're going to be porting a lot of our content over to this YouTube channel. We have some there already, but feel free to check it out and subscribe. Now, the next thing I want to talk about is a brand new inspector, which is being developed specifically for packaging, and it's compatible with our ChromaChecker Capture software. And for those of you that know Capture is our client software that interfaces with all the color measurement instruments that we work with, which I think the number's up to 14 different instruments now. And this new Capture interface is a cross between Print Inspector and Quick Checker, which means for product packaging, it's really flexible. You can take a color strip, measure, let's say, 20 colors in a color bar, and then measure 3 other colors that might be actual live artwork off the piece itself versus something that's just on the color bar. So it's really designed for packaging or complex spot color assessments. It has instant reporting within the Capture interface, and it has a lot of new operator guidance, which tells the operator increase density, decrease density, or reformulate ink because the ink isn't going to get you to your delta E tolerance that you're asking for. It actually has MIS integration, so you can take XML data from an MIS system, load it into Capture. It loads things like job, customer, tolerance, everything related to that job comes in through the XML file from the MIS system. And then we're adding the ability to track a lot of secondary variables that are contingent on how that press is running. When we're dealing with FlexoPress, you could have different sizes of analogs for different colors of your print, and you can record all of that within Capture, so you know if you do this job again, exactly which analogs was used for which ink and the sticky back and all these other secondary variables that greatly affect the print process. It will be an additional cost, but for people doing packaging, you'll see it's worth it. Here's one of the screenshots that shows you, in this case, 7 colors. And then you see the LAB cross section with circles showing the tolerances of where those colors are compared to the tolerance. So you can see if the color's too saturated or the wrong hue angle or what have you, which will help an operator better figure out what they need to do to fix the color to get in line. Here's another report graphic, and these are all available for all the inks as you saw in the previous one, or you can drill into one ink and just look at one ink in detail to know what you need to do to dial that ink in. Here's more of an overview of 7 different inks, and not only does it show you if the densities need to go up or down, but whether or not it's the right ink and what the parafarb is, what the dot gain is. So a lot of very useful information right at the press operator's hands. So if you're interested in beta testing this, please let us know. Email any of your contacts at ChromaChecker. I'm David at ChromaChecker.com, and we'll get you on the beta list if you're interested in testing this out. Now, we've also made some improvements with the project inspector reporting, and this is timely to today's session because it's showing in a timeline mode of how different colors were measured. And the more clustered these clumps, the more precise the measurements. The more the dots are spread out, like on the far right, the higher the variation is between these measurements. And when we're talking about one of the key problems is printing the same on the same press day after day, this helps you see how well the color is being produced. This is a real life customer job, and it's the same color. So on the left, the delta E should be the same between days. And you see there's multiple days in between when this job was run. And the tolerance, the delta E's, or the accuracy of this job at the beginning is pretty tight. And then over on the right, 2-3 weeks later, not so tight and higher delta E's than it was when they ran this job December 13th versus March 31st. So this is the type of information that tells you the press is not printing as consistently as it was, and maybe you need a new curve, maybe you need a new ink formulation, something to try to get that ink back in. And these reports that ChromaChecker is providing helps explain to you which route to go to solve the problem. Now, let's get into today's session, which came to me based on a recent poll by a RIP manufacturer where they polled 1,500 printers and they asked them what their biggest color problems were. And number one was not matching color on the same device between jobs. And if you can imagine, if you're printing a job for a customer this week, and then they come back next week for 10 more or 2,000 more, and it doesn't print the same, that's a problem. And yet so many printers don't realize that this is a common issue and that losing one job costs your company a significant amount of money. And we're going to get into the ROI in a few minutes, but this is a big deal. Now, the other two problems are not matching spot colors close enough and not matching color between print devices. We're going to cover these two topics next month's session. This month, we're going to focus on not matching color with the same device between jobs. And to really cover this, we need to go into some, we'll call it prerequisites, some background information to help you understand how we can check what the consistency is between the press. And it all comes down to defining what is a color match per your color expectations. And it ceases to amaze me that ChromaChecker is still really the only color conformance product on the market that defines what a company's expectations are for a color match and then tracks how each printing device manufactures color within those expectations. Everybody has a different level of expectations of how close two colors have to be acceptable. We've researched this, we've published this, and using this metric called E factor, we can define how close not only a printer is printing to itself over time in E factor, but we can define in E factor how close the printer is printing to a given reference, such as Grackle, and even more importantly, many times, how close one printer is matching to another printer in E factor, meaning is it within your expectations? Other programs say, hey, our printer is ISO 12647-7 compatible or compliant, or G7 color space compliant. From a color accuracy standpoint, that really doesn't tell you anything. When I tell you my printer is 1.8 E factor to Grackle, I know precisely how close that printer is hitting the bullseye. And this is a unique capability that ChromaChecker provides for all the printing devices that it's tracking. And by the way, it does it for light booths and measurement instruments as well, because they all have E factors as also. And the E factor of the instrument or the light booth can affect the E factor of the printer. So ChromaChecker ties it all together. And we're going to talk about precision. We're going to talk about accuracy, what the differences are, and how to decide whether or not the printer is capable of meeting those expectations and what tools to keep it straight. Now, this gets into some of the pre-basics of color management and what I call the 5 C's of color control. And those C's are capturing measurement data, because without measurement data, it's just an opinion. So you've got to quantify how printers, instruments, light booths are rendering color. Next thing, we have to calibrate our printers, instruments, and light booths and displays to make them consistent to themselves over time. So that's a big key to today's session, is ensuring that the device is consistent between jobs. Then sometimes you'll want to characterize the printer, which means building an ICC profile, which gives you more accuracy in terms of how that device renders. And if you build profiles for 4 different printers and 4 different substrates, you've got to have a way to convert the color between those 4 different substrates so that when you convert, you get the color you want on the device. And then most importantly, you need a tool that checks conformance to ensure that the printer is printing sellable color. And that's really what ChromaChecker does. ChromaChecker is a color conformance tool which assesses printers, light booths, instruments, and every other variable. And it can help with the profiling. It can help with the G7 curve creation. It can help you understand what the capture data does. But overall, its role is to be the referee. Is the printer in bounds or is it out of bounds, using a sports analogy? And if we look at the 5 C's, precision and accuracy is key for all of these. So on the left side, we have no precision and no accuracy, no color control. Next, if we've implemented a measurement device and calibration tools, we have capturing and calibration, which means we're consistent, but we're not necessarily accurate, meaning my printer is consistent to itself, but it's not necessarily matching Grackle, which maybe all my other printers are matching. So we could have a printer consistent in the 11 o'clock position and a printer consistent in the 4 o'clock position, and they could be 8 E factor difference, which nobody would accept. So it's a partial solution. Next, if we add a G7 curve into the mix, we can improve accuracy. So on the third bullseye, we have fairly accurate, but not very precise, because the printer is very inconsistent. And then on the right side, if we do both characterization and conversion with the calibration and the capture, we can have cluster prints right around the bullseye, which is the highest level of precision and the highest level of accuracy. So if we go back to our 5 C's, the first 2 C's are all about calibration, which ensures precision. The next 2 C's is all about ensuring accuracy. And then the 5th C ensures that everything's working together and you're printing sellable print. Okay? So when we talk about what level of color match is required, this is a key step that every plant needs to go through is you get the key decision maker, usually the financial stakeholder of the plant, and help them determine what level of color match is acceptable. Is this level of color match acceptable? Is this level of color match acceptable? It's dependent on the type of work and the type of customers you want to satisfy. Because you need to determine your plant's capabilities and set the tolerance to be uniform, no matter the operator, no matter the press, no matter anything. You can't skip this because this determines everything. I've had so many customers say, hey, you know what? My management just wants it out the door. Just print it faster. They don't care about quality. They print it black and white if they could get away with it, because the printer prints fastest in black and white mode versus color mode. Color mode slows it down. Why do we need color mode? We just run it black and white. No, because at some point, the customer is going to say, no, that color difference is too much. It's not acceptable. I'm not going to buy it. So E-factor allows you to choose what level of quality you're trying to hit. And to quantify this, here's 3 different prints from 3 different indigos. And you can see they're very different. Now, are they all sellable? Probably not. That third one probably is not sellable. And then here we have a situation where we did a scientific research quantifying with over 200 print buyers what they thought was acceptable. And it was really interesting in E-factor, what they came up with was that essentially 2 to 3 was acceptable for everybody. So if I just back up here a second, 2 to 3, everybody thought it was acceptable. Anything more than 8, everybody said it was unacceptable, which leaves us a big gap between 3 E-factor and 8 E-factor. By the way, E-factor is a type of delta E. It's the 95th percentile of the cumulative relative frequency of delta E, meaning 95% of those colors are within that number of delta E of one another. So this isn't a fancy formula. It's actually pretty straightforward. It's been researched and published since 2001. We're just one of the only companies using it this way right now, which is still shocking to me, but I enjoy being different. And so the danger zone for printers is typically between 3 and 8. And guess what? Most printers print between a 3 and an 8. So this is where you're crossing your fingers that when you print this job, the customer is going to accept it. So how do we address that? Well, we address that by defining what's too different. So if one is 2.5 to Grackle, and the second sample on the right is 4 to Grackle, and the third sample is 15 to Grackle, I think you could quickly say that, no customer is going to accept number 3. And depending upon the customer, hopefully they accept 2 and 1. And this is what's necessary to define what waste is. A whole lot of talk going on sustainability and being good for the environment. And nothing's better for the environment than eliminating waste. How do you determine what waste is? Oh, if it's not G7, it's waste. You will put your business out of business if you try to ensure that every printer on every job prints to G7. It's just not possible with most printing devices. So G7 is a great methodology. We use it all the time to dial printers in. I'll show you examples of how we use it to dial printers in. It's fantastic. But as a metric to define what is waste or what is sellable, it's horrible. It doesn't work. Because, like I said, you would go out of business. So E-factor is a metric to define what level of color match is acceptable for your shop. We've got shops that run at a 7 all day long and make money. We've got other shops that run at a 3 all day long and make money. So it really comes down to what level of color match is acceptable for you. Now, I talk about 1 and 2 pass G7, number 3 doesn't. Now let's go back to our graphic here of precision and accuracy. So no color control, I would say a good 40% of the printers that print today have no color control. It's any way, any day. And they're typically printing in 8 within a job, between jobs, different printers. They're off the chart. They're not accurate. They're not precise. If you've got precision under control, you might be down in a 6 range. If you got a G7 curve at play, you might get down to a 5 range. If you're using ICC profiles and color conversions correctly, you could easily be down in a 3 range, depending upon the type of printing device you're working with. And remember, not many companies use ICC profiles for offset presses. We typically use G7 curves for offset presses because trying to control all the variables of an offset press to make a profile last a long time is a challenge. Now, if you do control all these variables in terms of ink water, nip pressure, nip cylinders, fountain solution values, temperature and humidity, which, by the way, ChromaChecker tracks all these variables. So if you do want to profile your press, you can get an offset press down into the 3 range. We've got customers that do it. It's rare, but it's possible. But it costs more money to run the press at this level. But if you have higher end customers that are willing to pay for it and it differentiates yourself, there's your avenue to make money and be unique in the marketplace. Now, how this plays is this: establish the minimum quality requirements. Quoting from James Maxwell, it's a matter of balancing economy against quality. Too much throughput, meaning too little quality, you lose customers. Not enough throughput and too much quality, you lose money. So it's dependent on the print organization to understand their E factor and what they're trying to achieve in order to balance throughput and quality. Because if you're trying to use some, let's say, outdated digital presses and try to maintain them at a 3, you're going to go out of business because these older digital presses can't maintain a 3. They're lucky to keep a 5. So you've got to understand what your devices are capable of and then build your quality management program around that. And guess what? When you start looking at new devices, you better know what the precision and accuracy is of these new devices before you buy them. And guess what? No manufacturer is going to tell you what the precision and accuracy of their printers are. You're going to have to figure it out. And we've been asked for our benchmarking tools, which we have on our website. And we've benchmarked over 30 digital presses and multiple conventional presses to give you an idea of what's normal. If I have a J press, if I have a KM1 press, if I have an Indigo, if I have an iGen, if I have an Iridescent, what's the normal variation of that printer? We know all that because we've got all the data. So this is probably going to be a session maybe 2 months from now where we talk about what's real. What can you expect from different makes and models of printers? I'm sure I'm going to get some printer companies mad at me, but not the first time. I've had instrument companies mad at me and light booth companies mad at me because our system tells you how accurate and how consistent these devices are. And sometimes manufacturers don't want you to know that. So I like to consider ourselves like a better housekeeping seal of approval, that we're just a referee. Don't shoot the messenger. Don't shoot the ref. We are telling you how these printers are capable of printing. And to help you understand how this works, it would be helpful to go through an E factor exercise. This is available either in hard copy, which typically when you purchase ChromaChecker, if you get the starter kit, this includes this exercise. And the concept is that it will tell you what any 2 of these prints look like next to one another. So you could say, hey, I want to see what a 6 looks like. And it'll say, take the circle with the square, put them next to each other. That's a 6. You can also do it in a blind way, exercise way, where it says, put the circle and the polygon next to each other. Tell me if you accept that. And based on whether or not you say yes or no, it then goes to a different combination of color prints and then says, if the last two were not acceptable, are these two acceptable? And then you say yes or no. And it drives you to a response where it'll say you're a 2. And if you're a 2, it'll tell you you really can't be a 2 for the most part with today's technologies, unless you really track every variable and compensate for instrument differences and all these other things. But it sets your expectations that 2 is really hard. Whereas if you come out as a 5, it's like, hey, five's more reasonable. You come out at a 7, it's like, yeah, that's really reasonable. And typically, it's a quality process. You can't start at a 2. If your company's currently operating at an 8, you can't go to a 2. You got to go from an 8 to a 7 to a 6 to a 5, and ChromaChecker helps you do that. ChromaChecker helps you understand where your devices are printing now and how you get them to print to where you want them to print to. Like I said, there's no right or wrong. It's a matter of where you are. So when we talk about the 3 biggest problems printers encounter, not matching color on the same device between jobs, what level of tolerance are you expecting between these jobs? Are you expecting a 3 E factor between the jobs? Are you expecting a 6? What level are you expecting? We can track what you're currently providing, and then if it's not good enough, we can help you either build new G7 curves or build updated ICC profiles or find closer paper stocks, whatever is necessary to try to dial this job in better between different jobs. And then same with matching spot colors. How close is close enough? I mean, for most companies, close enough means within 1. And if your printer can't print this red, you're not going to get the 1. ChromaChecker can tell you if the printer can print this red. My HP here, my HP laser, no way can it print this red. But my Epson inkjet, oh yeah, it'll nail that red, no problem. So again, helping you understand, is it in gamut or capable or not? And then if it is in gamut, how do you do it? And we'll show tools in ChromaChecker that will tell you what the exact CMYK values are to make that color match on the Epson. And update it over time. So as the Epson moves, depending upon how good the calibration is on it, you might need to update your spot color lookup table so that that Ritz red stays Ritz red over time. And then, of course, the biggest challenge, really the biggest challenge for a lot of printers is making multiple printers match one another so that I can print a job one day on that printer and the next day on that printer, and the customer's not going to notice that there's a color difference. That's ideally what printers need to be able to do, is have flexibility on where the prints are happening. So let's delve more into this problem number 1. And by the way, guys, Beth's monitoring the chat. I'm on a roll. If you guys have questions, feel free to ask the questions, and Beth will interrupt me. So number 1, not matching between jobs. We're talking about precision and consistency. If we talk about an offset press and we print 5, 6 different jobs, how close are those jobs to one another? Well, obviously there's going to be some amount of variation between an operator, but also there's usually a fair amount of variation even within the same operator. And so same with the digital press. So now notice we've got a dart target out here, and we've got dart holes in terms of how the press printed job 1, job 2, job 3. We can quantify in E factor how close these jobs are to one another and how consistent the job is within the job. So we're talking about within page uniformity, between page uniformity, and between job reproducibility. ChromaChecker using E factor tracks each of these variables, which are all super important. Now, when we talk about precision, which is the consistency of the printer, we have within page consistency, within job consistency, and between job consistency. And I've taken a screenshot from ChromaChecker and real data from an offset press, and you can see the green line is at a 5E factor. So anything under a 5E factor, it's if you will, passing. Now, in this case, the blue line represents the within page consistency. So when you have an offset sheet, how consistent is the color in this ink zone versus this ink zone versus this ink zone versus this ink zone? If the press isn't very consistent, and you can see this blue line is kind of going between a 1 and a really 1 and a 4. That's not very consistent. But I can tell you this press does not have good ink presets, nor does it have closed loop. So ink presets and closed loop will help make the press more consistent because it'll help level out the ink keys within the press, which makes the consistency of the color on the press that much better. So if you have an operator with a handheld device manually hitting the ink keys and opening them, you're going to have this type of variation, which means you better not accept jobs where the customer is requiring a 3 because you don't have the infrastructure, meaning closed loop and presets, ink key presets, to handle a 3. The best you're going to be able to handle in this type of scenario is a 5. And it's your accuracy is totally limited by the level of precision. And the red line here represents how consistent the job is within the job. And if one job was let's say pull 0 through 40, that could have been job A. And then pulls 40 through 85 were jobs B. And pulls 85 through 100 were jobs C. So here it's telling you how much it's varying between the jobs. So everything you're asking for in terms of how much does your press move, it's right here. And you can see it on the right side, it's starting to peak. And when it starts to peak like that, it really tells you it's getting out of control. Now, I've added a third line here, which is the amber line, which is the accuracy. Because consistency is key, but accuracy is seldom. Meaning how accurate is the press to grackle? And this has to do with how good in an offset press, how good the plate curves are. So when you're looking at this press is probably 80% conforming, meaning 80% of the measurements are below the green line. About 20% of the measurements are above the green line, which is the E factor. And typically we know what we know that if your accuracy is around a 4, if your precision is around a 4, your accuracy is going to be around a 6. It's typically 20 to 30% more than your precision. And you can see in these lines, and once you see your data here, it's this way every time. So I had a customer here, they kept on wanting to pull a new G7 curve because they wanted to improve the accuracy. And I told them, you can pull a new curve all you want. You can even build an ICC profile. You're not going to get any more accurate than this precision will allow. You need ink presets and closed loop in order to make this press more accurate. Curve's not the problem. It's the precision and accuracy which is the problem. Now, when people say, hey, what's more precise, an offset press or a digital press? So take a look. I'm taking an extreme digital press. This is a inkjet digital press from one of our customers. And look at the numbers. The E factor, the peak E factor is under a 2. The tolerance is set for a 3, but it's pretty much maintaining color at under a 2. That's like an Epson. And this is not an Epson. This is an inkjet type printing device, which is crazy precise. You can see both the blue and the red lines. And by the way, these are in scale. So if I go back, here's the offset press, here's the inkjet. These are in scale. This inkjet is 3 times more accurate than the offset press. So quite interesting here. Now, not all inkjet presses are like that. This is one make and model that I found to be super good, but not all presses perform that well, which is why we need to do another one of these benchmarks of the industry, the state of the industry. The last one we did was probably about 4 years ago. So we're due for an update to see how the best of the best presses are performing today. Now, as I mentioned, once the E factor of the precision gets within 20% of the accuracy E factor, that's typically time to update the G7 curve. So over time, if you see the G7 curve kind of living around a 3, and then all of a sudden it's living around a 4, and you're trying to keep this press to a 5, if your E factor of precision is a 4, it's time to update the plate curve, because the press has moved to such a state that it's no longer in line with the curve, and you need to improve accuracy, build a new curve. And remember, precision's not always enough, because when we're talking about accuracy, whether we're talking accuracy to, let's say, an ISO or a Grackle standard, or we're looking at accuracy to one another, we could have really good precision by multiple presses, but really poor accuracy in terms of how these presses match in trying to print the same job. So when we talk about industry references, in the US, we typically talk about Grackle 2013 for coated. And so you need a target to aim the printer to. And this is even valuable if you only have one printer, because I've had customers that have one printer and they didn't have it targeted to something like Grackle. And then when the printer died, they bought a different make and model of printer, and they could never make that printer match the original printer they had, because no two printers print the same gamut or the same range of color. And so they had a lot of ticked off customers because they could never match anything that they had printed for that customer earlier. If they would have had that single printer lined up with an ISO coded standard or a Grackle standard, and then when they got the new press, they would have benchmarked it to make sure it was capable of hitting the Grackle standard within the same E factor as their original press, then they wouldn't have had any problems matching between jobs, because both printers were hitting the same reference. Now, not all printers can hit a Grackle reference. Some can actually do better. So there's actually 7 G7 based references that are available. One's called CRP6, which is Grackle coded, but there's a 7th one called CRPC7, which allows you to take advantage of more color that your printer can print, which is capable with some printers. And then there's 5 gamuts that are smaller than Grackle, which accommodates things like uncoated paper and PVC and other types of paper stocks that don't have as much range of color as coated. And so using these different references, you set your printer up to aim for them, and then using a color conformance tool, you track your printer's conformance and precision. Now, when we're talking about conventional presses, each operator subjectively decides if the sheet is close enough. And I'd say 95% of offset printers still do it this way, which is really crazy. If you think about it, the operator gets his press up to color, he gets to look at the press sheet, and he gets to determine when the press in its current state is deemed an okay sheet to be close enough to the proof. It typically doesn't represent Grackle. It doesn't mean it's going to match from day to day. And so what I want to do here is just pop out of my presentation and play a audio for you that one of our customers recorded. And this just takes a minute, but the guy came from the bindery, and he was used to KPI, key performance metrics, key performance indicators. And he came over to the press room, and here's what he says.
Before moving into the press side of the business, I had spent my career on the finishing side in the bindery, where the success metrics are objective. if the customers ask for 3,000 books and you've only produced 2,900, you know that you haven't hit the mark, you know by how much you've missed and what you must do to be successful. After spending a little bit of time in the press world, I was surprised to learn that a successful match is based on the subjective opinion of the press operator. This was hard for me to understand. I couldn't believe it and made it one of my top priorities in trying to find an objective way to discern match and the meeting of customers' expectations without having to rely on the feelings or subjectivity of the press operator at that day and at that moment. After a while, I found ChromaChecker and am ecstatic to start working.
So here, that's a key thing that I'm just shocked to this day that depending upon the time of day, depending upon the what the press operator has going on, they can just choose an OK sheet at any time. And then every operator has different expectations of what's an OK sheet. So now all the operators are delivering different levels of quality for your shop. How is that a quality mindset? So most of our customers, once they start implementing ChromaChecker within their presses, they tell the operators, hey, you have to achieve something less than a 6 E factor or maybe a 7 E factor before you pull an OK sheet. So now you're dialing all the operators into the same level of quality. And now you can start judging things like how long does it take operator A to get to a 6 E factor? How many sheets of make ready do they go through? How many sheets of make ready does it take operator B to get to there? So you're judging them all at the same level of quality. And now you're seeing how well they're actually getting the press up to that level of color in a short amount of time. And it helps you understand which press operators need more training or more work. And in this way, you have a common tolerance that aligns for all press operators, and it's based on E factors. So you know right away if the jobs are good or bad. Now, in conventional printing, when does the plate curve need updating? Well, I kind of showed you with the baseline when it needs printing. So let's come back here and say, hey, if you start seeing that you're hitting your solids and one of the dot gains is off, like in this case, the black is light. Actually looking at this, I see the black solid is a little light because you can see in the parafarb, it needs to increase about 14 points of density. So let's just assume we were at the right black density. We're acceptable now, but it could be better. But our dot gain still was thin. Well, I'd start looking at that unit to fix that unit. Maybe there's too much packing or the pressure between the cylinder and the blanket's wrong. But I'd be looking at the unit to fix to get it back lined up with how it should be operating. Whereas if all the dot gains are high, like in this case, that could be a change of season. So what we typically see in a change of season is that the viscosity of the ink as it gets warmer gets looser and we get higher dot gains. So especially coming from a cold climate like I've come from, a lot of my printers had a plate curve in the winter, and then they'd update that plate curve come late spring, early summer, when everything started gaining and the viscosity was different, and they had to update the plate curve to keep all their dot gains in line. So this is another very useful way to know when to update the plate curve. Now, in terms of digital printing, most of these operators were flipping burgers last week at McDonald's. So they don't know how the printer's printing sellable color. And you as an owner are guessing, hoping, and praying that everything's going to work out. Well, guys, whether it's digital printing or conventional printing, how many jobs get printed and rejected by a customer? Every printer has jobs rejected by a customer. Did you know that waste completely destroyed its profitability and sustainability. Due to a Printing United industry survey, 75% of printers in the market in North America today make 2% margins or less on sales. So the top 75% are making 2% margin on sales, which means if you have a job that you print and the customer says no, or you give them even a credit for $200, it requires your company to have an additional of $10,000 in sales to cover it. And you get that by taking 200 divided by 0.02, and that's $10,000 in new sales to cover this $200 makeup. People say, oh, I can't afford ChromaChecker. It's like, are you kidding me? If you buy 5 at a time, it's $715 a year. Almost all of our customers say ChromaChecker pays for itself every week because it eliminates this waste. So this is why printers are going out of business, because you can't sustain a business at 2% margins and not control color, which means you're still giving customers free jobs and writing things off, and you're just going to go away. It's not sustainable. You're going to go away. So get a quality mindset, get a system like ChromaChecker in here, and just to show you how easy it is for an operator to run ChromaChecker, I'm going to just come here to capture kind of on the fly and show you how even a digital operator with no knowledge, here's a video that shows them how to use whichever device they're using. So I'm using an i1, so it's a video on how not only to use the i1, but how to use the i1 with the capture software. I'm going to go in and I'm going to go ahead and just measure this color target. And I'll just put it in this track. So after I've seen the video, I can just come over here. I can take my target, measure it quickly, and at the end, ChromaChecker is going to tell me if the target passes or fails conformance, if I measure the target correctly. So let's try that again. And notice, first time I went left to right, second time I went right to left. It doesn't matter which way you go. It's got an algorithm that helps you figure it out. Or you don't have to figure out. It figures out which way you scanned it. And now when I measure the last row, it should come up with a bullseye showing me how close I am hitting to the target. Look at that. I'm 5.6. I'm allowed a 6. I'm right on the edge. I'm right on the edge of the target. So I'm passing. It's good to go. It's not going to be waste. Now, let's say it's failing G7 and I needed it to fail G7. I can click on this G7 button, and from this target, I can iterate a new plate curve or new tone curve in a format like an Adobe tone curve or a CGATS file or a Fiery VCC file. I can just calculate it. It'll download it to my computer, and I can load it into my RIP and keep going and get the device more in line. And I'll show you with a customer that actually did this. And he was using ChromaChecker to do his color. And then he saw one of his printers was, I think, a 6. We'll look at it in a minute. And he did a new tone curve for his printer, and it came down to a 4.8. And he was like, oh my goodness, this is unbelievable. Because he was aligning, not only was he keeping the printer consistent between jobs, but he was starting to align the printers to one another. And this is what the data looks like when you look at it in ChromaChecker, in that this is a digital press. You see a 6E factor, and you see the red line is the consistency. The amber line is the accuracy. And again, like I said, the consistency here is about a 3, and the accuracy is about a 5, about 20% more of your E factor. And then the blue line is the within sheet variation. Now, this digital press isn't nearly as consistent as the digital press I showed you earlier, but it costs a fraction of what that other digital press cost. So again, you get what you pay for. And the beauty is with ChromaChecker in terms of this baseline is you build a new baseline every time after you've verified your G7 curve, your ISO curve, or your ICC profile, because that's as good as that printer's going to be working. From then on, it's only going to get worse. So you want to be able to see as that printer drifts, like in this case. This is the exact same model printer sitting right next to the first printer I showed you. And you can see in February it was profiled. In March, the baseline went from 3 to about a 4. And then April, it started going to a 5. And then the accuracy started failing. This is when the printer should have been reprofiled. Because even calibrating every day, the calibration was not keeping the printer in line. There was so much maintenance being done on this printer that the characteristics of how this printed color was different. It needed a new ICC profile. But at that time, the customer didn't know any better. And so they were getting more and more fails as time was going on. But now they know a lot better. And so they can fix that right away. And if you notice the blue line on the left side of this graph, they had some within page uniformity issues going on this printer as well. And that first vertical or that second vertical gray line going up and down was the maintenance event that they did to fix that first internal variation, which they had going on with the black ink. Here's another digital printer. This one was set for 3.5 E factor, and it was going pretty well. You know, you have occasional bumps where you see that red line pop up. It's because something broke on the printer and it went from printing a 3 E factor to a 12, and the operator found it right away, fixed it, got it right back down to normal. But then you see this ski jump off the right side, it starts drifting, and I'm not even showing the amber line here. And the amber line here would be above the red line, but you can see when the baseline starts drifting, it's time to update the profile or the curve. So now, here's my call to action, guys. I want you guys to see with your printers how this works. So if you have conventional presses, if you have a modern automated scanning system that can export data, start exporting the data. And if the system doesn't automatically save, we've got a free utility that we can give you that will automatically make a copy of every export. So at the end of, let's say, 2 weeks, you'll have 1,000 files. And we'll help you import those 1,000 files into ChromaChecker to see your press, how consistent it is within jobs and between jobs over time. And it becomes a mind-altering experience because you are seeing your press in E-factor numbers. And depending upon if the operators are logging in, you'll see which operators are doing best, which ones aren't doing so well. It's really eye-opening. And especially if the operators are selecting make ready or production as part of these prints, it's really great. If you don't have an automated scanning device, then we can give you a target, like one of these 2 targets, that ideally you can find a place in a live job that maybe not every job, but maybe 1 every 4 jobs, you can find a place to put it in the job. And then just tell the operator when this job is running after they pull an OK sheet, pull a couple for you so you can measure after they pull an OK sheet how consistent the press is between jobs. And we'll show you how to measure these and bring them into ChromaChecker to see how this works. If you have a previous measurement data, so if you've already done like P2P targets or the Idea Alliance 3-row target for proofers, if you've already got the measurement data in your hands, work with us. We'll set up a trial account for you so you can, again, upload the data that you've already collected and help you analyze how consistent the press was through the run, between runs, between presses, all this type of thing. If you don't have any existing data, we'll give you a PDF that you can print on your printers over time and then measure the target. And that's what I did with this one customer is I provided this PDF and he printed this PDF on his 4 different printers. And one of his printers was a 2.1, was 4.6, one was 5.6, one was a 3.9. And then he can take these prints and visually compare them to one another. And he can visually compare to the print called master, which in our TR016 kit, there's, if I can find it here, I got my prints all mixed up. There's one called master right here. This is actually matching Grackle. So you can actually see what's matching Grackle to how the press is matching Grackle. And I had a customer recently who they were using a Canon device, and the Canon inkjet device, nice and consistent, but it wasn't accurate. For whatever reason, it wasn't accurate. And his Canon device, they had to use the Canon toolbox to build a profile to dial it in. And so he went to his manager and he showed him how his Epson was a 2E factor to Grackle. Their presses are running about a 4, but this Canon press was like at a 6 or a 7. And he showed him what a 7 looked like this. And he said, to make it better, we're going to have to buy the Canon profiling software to dial it in. And when the manager saw how off it was of Grackle visually, with a number that said this is 6 and the rest of our devices are 4, he found the money to pay for that Canon software to dial that Canon in better. Now, in this case, this scenario, I'm going to show the real ChromaChecker setup, because I had the customer use Capture and measure these samples in. Here's the Acuity, the Epson, the Inca, and the Zycon. And you can see these printers. And if I go to the Acuity, you'll see that the first print on the Acuity, it was a 7.8. And then he built a new G7 curve, just like I did a second ago in Capture. He loaded it into his print factory rip, and it came down to a 4.3. And then he did it a second time, and it came down to a 3.9. There's law of diminishing returns, but he got the Inca down to 3.9, which he was ecstatic about. And then you can start comparing how close are the printers printing to one another. So you can click on this, and it's getting ahead of myself for next week's session. But you can see the Acuity to the Epson is 4.8 E factor. The Acuity to the Inca is 2.3. So those two are pretty well lined up. The Acuity to the Zycon is 8.5. And if I click on that 8.5, it's telling me, hey, the substrate is 6.7 difference. Paper is the 5th color and 4-color printing. Got to align the substrate before you try to align these printers. So it's ChromaChecker as a way to find a better matching paper for either the Zycon or the Acuity to better line them up if you've got jobs that have to match between the Zycon and the Acuity. So these are unique functions that I don't know of any other system on the planet does. And it helps you understand not only how precise and accurate your printers are, but how aligned your printers are to one another so that you can get them lined up. So we're running out of time. So in summary, making printers print the same over time, it's all about measuring your prints and recording the changes as whether you're updating the curve, you're redoing the calibration, you're changing the corona wire, whatever. Record the changes to learn what causes your printer to drift. Conventional presses start requiring OK sheets to be within a certain E factor limit. And I didn't mention this, I should mention this. ChromaChecker, when we're dealing with an offset press, you can aim for an OK sheet. It's okay. In fact, unlike any other solution I know of, you could have 3 conventional presses aiming for the same OK sheet. So if you made an OK sheet on Komori 1 and you want Komori 2 and Komori 3 to hit that same OK sheet, ChromaChecker lets you do that. Or you can aim the press to an industry standard like Grackle. Once you start checking your consistency of your presses, you'll know when you need to update the G7 curve versus just doing it, let's do it once a year. Or let's do it when enough customers complain and threaten to take their business away that we should. That is not a quality mindset. A quality mindset is know when to update your plate curves based on the press going out of your tolerances for expectations. Digital presses, give your digital press guys a $1,500 instrument and Capture and have them measure the color before they run jobs during that shift. because just saving $200 will save an additional $10,000 of sales for your company. Guys, educate management. It's about sustainability. We'll help you get started. If you already have data, Larry and I, over the next, well, actually, I'm going to make it infinite. You guys have data. Reach out to Larry at ChromaChecker.com or myself, David at ChromaChecker.com. We'll set up a way to get your data. If you already have data, we'll take your existing data, we'll load it into ChromaChecker so you can see what that data looks like. This guy that did the Inca and the onset, he did these prints. He'd been waiting to print his target for a year. He hadn't gotten around to it. He knew ChromaChecker looked interesting, but he hadn't gotten around to it. Once he printed on the Epson, he had a 2.1. It showed him how good it was. And then he did it on the Inca. He had a, 7.8. And then he did the curve and it got the Inca down to 3.9. That guy worked till 2 in the morning with his crew because they were so excited about dialing their printers in for the first time. He said to me, "How much do I have to pay you for this so you don't sell to anyone else in my territory?" He was like that ecstatic about this. So next week, we'll get into how to optimize your spot colors and how to align your printers to one another. But that concludes the session for this week. God, did we have any questions, Bob? It doesn't look like we did. I feel bad. But
We
no.
did not.
Okay, well, I hope it was informative for you guys. And this will be up on the recording, tomorrow or the next day. And if you guys have any questions, feel free to reach out to me. I'm here for you. And like I said, we want to help you get the data in here. If you're a dealer and you want to grab your customer data to get it in, we'll help you do that. We have a whole certification program for dealers and for customers to help prove that you know what you're doing. And it's going to make your company a lot more sustainable and a lot more profitable. So with that, guys, ciao, appreciate it, and be safe.